Good morning. We are going to continue multiplying vectors, and we are going to do the cross product now. So the cross product represents the area in between two vectors. So if we have a vector A cross the B, so let's say I'm going to kind of try to do this in show this in 3 dimensions. Let's say we've got two vectors, A, I'm going to use capital A and B. And we cross those, this is the angle between them. It represents this area in between, this area A times B. And then it comes up, it's kind of cool, it comes up out of the paper. So it has a totally new direction. So this vector here becomes A cross B, and it comes perpendicular to the plane of A and B. Okay, so you can find it 2 different ways. So A cross B is equal to the magnitude of A times the magnitude of B. So it's very similar to the dot product. But instead of the cosine for the dot product, they use sine of theta. And that will give you the value of A cross B, this magnitude of this vector. So, for example, let's say you have that this was 30 degrees. So let's just do a quick example 1 here. So let's say vector A, the magnitude is 5. Vector B, the magnitude is 10. We'll make it really easy. And our theta equals 30 degrees. So to find the value of that, we would just say A cross B is 5 times 10 and sine of 30. Well, we all remember sine of 30 is, yeah, you got it, 1/2. And so we get 5 times 5 is 25. And then to get the direction of this, it's kind of cool. You take your right hand, so the right hand like this, and you make a gun out of it. So like you're gonna shoot somebody in play, right? And then what you do is you line up your index finger along A, or the first one that you're crossing, the first vector that you're crossing, A, and you curl your hand towards B, and then your thumb is coming out of the paper. So we write that coming out, we write that as like, it's supposed to look like an arrow point is out of the paper. So this would be out of the paper. And then if it was going, if you did B cross A, watch how it would change. So here I made my gun, and then I'm gonna go like this. I do B, and then I have to curl towards A. And so then my thumb is going into the paper. If it's going into the paper, it's supposed to look like this, like the tail of an arrow, like the feathers. That's going in. So this gives you the direction of your vector here. Okay, so out of the paper is the point. That's when your thumb is coming up. And then when your thumb is going down, and you put the little cross marks. Okay, so that's called the right hand rule. Right hand rule. And rule. And I'll just put that, make a gun. Make gun. And of course, you're using your right hand, otherwise it's not going to work. Point, index finger, pointer finger along A, vector A, and then turn towards B, or curl your fingers towards the B. Okay, so this is something, you guys, for crossing. Oh, you might not be able to see all that. Sorry about that. For cross product, it's used a lot in physics. Again, it's used for torque and angular momentum, things like that, because just like when you're, when you're riding your bike and the wheels are turning, right? And the faster you go, the harder it is to tip that bike over. That's the angular momentum, the speed of your bike or the velocity of that wheel, and the distance from the center of the wheel, that radius, times the force along that wheel. If you crossed those two, you would get the direction of your angular momentum or your torque. So let's say you have a wheel like this, right? You've got your radius R, right? And your force, let's say you're spinning this direction, and your force in this direction. So torque, they use this cool Greek letter, torque, is equal to that radius vector crossed by your force vector. And when you do that, if you did the right hand rule, right, you do the radius and you'd cross it. And then that torque is coming directly out of the wheel, this direction. And you can definitely feel that. The faster you ride your bike, right, you can't tip it over, because this force being crossed, it makes that angular momentum or that torque force really, really strong. It makes it hard to tip over because it's coming out perpendicular to the wheel. Anyway, that's just our physics application. And you'll get that more with Mr. Haugen next year when you guys take physics. So that's just an aside. So all we're going to do on our homework tonight is we're going to do cross product with components. And the reason we studied determinants the other day is that's the way we do the cross product. So if we have vector A, and we've got, this example 1, can you guys see that? No, not quite. There we go. Example A, X, A, Y, A, and Z, A, right? And we're going to cross that with B. And let's say we have X sub B, Y sub B, and Z sub B. Okay, so the way you cross them is you do the determinant. And your top row is I, J, and K. That'll give you your directions, right? And then you just fill in X, A, Y, A, Z, A, and X, B, Y, B, and Z, B. And then find determinant. And so we would just do, we're going to cross these. Oh, and we would copy these over, right? X, A, X, B, and J, Y, A, and Y, B. And we're going to cross those over, right? Oops. Uh-oh, I messed up there, didn't I? There we go. And then we go this way, and this way, and this way. And remember, for the determinant, we're going to multiply across, and add the bottom, add top. And then the determinant is bottom minus top. You guys can't see that. So those are our steps. Okay. So let's do, no, I think I'll leave it there. You guys can try the homework because we've done determinants before. So give it a shot, and I'll post the answers tomorrow for you. Okay? Thanks so much. Bye.